Hey everyone, welcome back to the channel. In today's video, I'm talking about Lewis dot structures. Lewis dot structures are representations of chemical compounds. They help you find the shape of a molecule, and they can also predict how it will react with other substances. Let's learn how to draw Lewis dot structures. First, we want to find the total number of valence electrons in the molecule. You may have heard your chemistry teacher say that valence electrons are what allow elements to react with one another. That's why we need them to draw these diagrams. In this video, I'll be using N2O as my example, which you may recognize as laughing gas. N2O has one oxygen atom and two nitrogen atoms. An oxygen atom has 6 valence electrons, and a nitrogen atom has 5 valence electrons. But since we have 2 nitrogen atoms here, I'm going to write 10. Adding these two up, we get 16 valence electrons. For step 2, we need to draw an outline of the molecule. We'll start by drawing the central element, which is usually the least electronegative element. If you're unsure about how electronegative an element is, you can always check this table that I've linked in the description below. It'll give you the electronegativity values for each element. The higher the number, the more electronegative the element is. You can see here that oxygen is a 3.5 and nitrogen is a 3. Which means nitrogen is definitely less electronegative. So we'll put a nitrogen atom in the middle, and surrounding it we'll have an oxygen atom and another nitrogen atom. Then we'll connect these initially with single bonds. I'll talk about double and triple bonds later in the video. Step 3. We need to start filling in electrons, starting with the outside elements. Remember, we need to use all 32 electrons, and so far we have 4 from the 2 single bonds. A single bond counts as 2 electrons because atoms connected by the bond share 1 electron each. As a matter of fact, you could rewrite this using electrons instead. So let's get started by filling in electrons. I have 4 right now, 6, 8, 10, 12, 14, 16. Okay, so now I've used up all 16 electrons. The oxygen atom has its octet filled because it has 8 electrons. The left nitrogen atom also has its octet filled because it has 8 valence electrons. The problem is the central nitrogen atom only has 4 electrons. That brings us to step 4, making double and triple bonds. When this situation happens, we can convert some lone pairs like these and these into bonds. This is really cool because sharing electrons lets both atoms keep their octets. Now, remember when I said that oxygen is more electronegative than nitrogen? Because it likes electrons more, oxygen is less likely to share electrons than nitrogen. So, this left nitrogen atom is going to have to share its lone electron pairs. So I'm going to take this lone pair off this side and put it here in the middle. If we do that once, we can see that it's not enough because the central nitrogen atom still has only 6 electrons. So let's do it again, but this time we're going to use the other side. So I'm going to rip a pair of electrons off of the oxygen and then make it share it with the nitrogen. So this way, the oxygen atom is still keeping its 8 valence electrons. But now, the central nitrogen atom also has 8 electrons. So this molecule has octets filled for all 3 elements, and this is the Lewis dot structure for N2O. We can redraw it using bonds instead of electrons, so that would look something like this. Now that I've worked through this problem with you, let's do some practice problems. You can pause the video at any time and then check your answers as I go through the problems. So here we have CO2. Let's get started by counting the total number of valence electrons. Carbon has 4 valence electrons. Oxygen atoms have 6 valence electrons, but since we have 2 of them, that gives us 12. I'm going to add these up, and that gives me 16 valence electrons. So now let's get started by drawing the outline of the molecule. Carbon is the least electronegative element in this molecule, so it's going to be the central atom. So we're going to have 2 oxygen atoms connected on either side, and I'm going to start off by connecting them with single bonds. I've just used up 4 electrons, which gives me 12 more. So let's get started by filling in the octets for the surrounding oxygen atoms. So I have 4, 6, 8, 10, 12, 14, and 16. So I've used up all of my electrons, and now I'm going to check the octets. Starting with the right oxygen atom, if I take a look here, I can see it has the single bond, which represents 2 electrons, with 3 lone electron pairs, which gives it 8. So the right oxygen atom has its octet filled. Looking at the left oxygen atom, it also has a single bond and 3 electron pairs, so it has its octet filled. Now, looking at the central carbon atom, it only has 2 single bonds, which gives it 4 electrons. It needs 8, so it doesn't have enough. So now we can go ahead and make double or triple bonds. I'm going to take a lone electron pair off of this left oxygen atom, and I'm going to add it here as a bond. You can see that gives carbon only 6 electrons from the double bond and single bond, so I'm going to repeat the same thing over here on the right hand side. Take away a lone electron pair and turn it into a bond. So now let's check for octets. The 2 oxygen atoms are identical because they have a double bond and 2 lone pairs, which gives them 8 electrons. As for the carbon atom, we can see that it now has 2 double bonds, giving it 8 electrons. So the octet for carbon is complete, and that means the final form of CO2 is this. Now let's do one more practice problem. Okay, here we have NH4+, otherwise known as the ammonium ion. So we're going to get started by counting the total number of valence electrons. Nitrogen has 5 valence electrons. Hydrogen atoms have 1 valence electron, but since we have 4 of them, I'm going to write a 4 right here. I'm going to add these up, except I also have this plus sign right here. Now, that plus sign means that this is an overall positively charged molecule. Because this is only +1, we can tell that this molecule has lost 1 electron, so we can subtract that 1 away from the total number of valence electrons. So 5 plus 4 is 9, minus 1 gives us 8 valence electrons. Now, let's go ahead and draw the outline for this molecule. Hydrogens can never be the central atom, so we're going to have our nitrogen atom in the center, and then we're going to connect 4 hydrogens to the nitrogen atom. So far we have 4 single bonds, which represent 8 valence electrons, so we've actually used all of our electrons up, and that means that this is the final structure of NH4+. The only thing I would recommend doing at this point is drawing brackets around the molecule and then writing a plus sign here to show that this molecule has a +1 charge. That's all for this video. If you found it helpful, please be sure to like and subscribe, and make sure you share this with your friends if you think they'll find this helpful too.